Hi, Laura. How are you doing today?
I'm very well, thanks, Alison. How are you doing?
I'm good, thanks. Before we get started, we wanted to do a very quick introduction for both ourselves, who will be facilitating the webinar, and to our experts who will be delivering the presentation.
Thanks, Alison. Yes, briefly, my name is Laura Llewellyn, and I'm the marketing manager for the Connected Technology division within Elements EMEA region, and I'm based in the UK.
Thanks, Laura. My name is Allison Moody, and I'm also the marketing manager for the Connected Technology division within the Americas region at Element. And today, our global experts, Michael Darby and Steve Liu, will be hosting a webinar on Wi-Fi 6E, where they will be discussing the testing and certification requirements for faster global market access.
Our first speaker today is Michael Darby, the Technical Director for Regulatory Approvals within the Connected Technologies Group. Michael has been in the EMC and radio compliance industry for about 32 years now. He started work for an equipment manufacturer testing for compliance and fixing technical failures. He then worked for commercial EMC and radio test labs before becoming a TCB notified body. He is the Vice Chairman of the TCB Council Board of Directors and the author of many technical papers for the RED Notified Body Group, the RED CA. Michael joined Element in 2020 and supports colleagues and customers from his home in the UK.
Thanks, Laura. After Michael's session, our second speaker is Steve Liu. Steve is the VP of Engineering for the North American Regulatory Approvals within the Connected Technologies Americas unit at Element. Steve has been in the RF safety, hack, and radio compliance industry for about 22 years. He began at PC Test in Maryland, testing 2G phones for RF and SAR, and soon grew the engineering team to support RF safety and RF exposures and SAR, hack part 20.19, and FCC PAG approval needs for the next generation of wireless devices, including 5G and Wi-Fi 6E. Steve works closely with the FCC, ISED, and the in-house telecommunications certification body, TCB, for unlicensed Part 15, 18, and licensed 22, 24, 25, 27, 30, 96 approvals, as well as Canadian RSS 102 regulations for complex novel devices, including smartphones, folding, and wearable products. Steve joined Element through the acquisition in 2019 of PC Test, but has been serving the wireless industry based in Columbia, Maryland since 2000.
Oh, thanks, Alison. And before we hand over to Michael, I wanted to encourage attendees to submit any questions you have in the GoToWebinar panel to the right-hand side of your screen. And if you do have trouble connecting, please refresh your browser or re-enter the GoToWebinar platform. Thank you, and I shall now hand over to Michael.
Hello, everybody, and thank you very much for the introduction. So I am Michael Darby, and I'm going to talk about Wi-Fi 6E radio compliance. There's me for my information. And so firstly, I'm going to start by talking about what is Wi-Fi 6E? For example, how does it compare to Wi-Fi 6? We're going to start off with the USA's FCC and ISED Canada, and then on to the Radio Equipment Directive for the EU and the UK's radio equipment regulations. Then I'll pass on to my colleague Steve Liu. He'll talk about RF exposure, and we'll have a Q&A session at the end. Now, I only have a short time to talk about a really big topic here. There's a lot of FCC KDBs and ETSI standards and European Commission decisions and Canadian documents out there already. I decided to base this presentation on the sort of frequently asked questions and most common mistakes, because I thought, I'm sure you can read those standards and people don't tend to ask me, what's the output power limit or what's the spurious emissions limit, because those are things that people can read in the standards. So instead, this is based more on what do people actually question me about and what do people struggle with. Okay, so firstly then, what is Wi-Fi 6 or Wi-Fi 6E? And probably, as a lot of you, like me, when you first heard these terms, you weren't sure if they were the same thing or not. So Wi-Fi 6 is a protocol standard. It's actually a name given to a stage in the evolution of Wi-Fi technology. IEEE 802.11ax is the standard that gets known as Wi-Fi 6. My first ever training presentation around the year 2000 was on 802.11b. Meanwhile, Wi-Fi 6E is the name given to the upper frequency band around the sort of upper 6 gigahertz, 7 gigahertz band that's been allocated for Wi-Fi type equipment. So Wi-Fi 6 is a Wi-Fi protocol standard. Wi-Fi 6E is the name given to the frequency band up around 6 gigahertz, commonly used by radio equipment such as Wi-Fi equipment. So to make that a bit more clear then, we've got Wi-Fi 6, 802.11ax. It's a Wi-Fi protocol standard. What makes it different to previous Wi-Fi generations? Well, we've got things like multiple user MIMO, we've got OFDMA, we've got really wide signal bandwidths, 160 megahertz wide channels. And one of the things that the technology can do is talk to multiple users all at once. So this is the multiple user aspect. So you can have little resource units allocated to different users in that 160 megahertz band. So this is a really high amount of data rate compared with previous versions. It doesn't actually matter what frequency band you put that in. Wi-Fi 6E, on the other hand, is new radio spectrum. So this is more of a sort of hardware solution, if you like. Radio spectrum around the 6 gigahertz area. So typically, for example, if you wanted to implement those Wi-Fi 6 wide bandwidth signals, you might choose to use the Wi-Fi 6E frequency bands. One of the benefits, of course, is that there's a great deal more spectrum to use. One of the things that's troubled 5 gigahertz Wi-Fi is the DFS testing or the interference with weather radar. And the benefit of the Wi-Fi 6E band is that that problem doesn't exist up there. So, for example, people are already working on what is getting known as Wi-Fi 7. So that would be the next protocol standard, 802.11be. Again, just another Wi-Fi protocol, but with 320 megahertz wide channels, even more data rate, regardless of the frequency band. So I don't imagine we'll be talking about Wi-Fi 7E because remember, Wi-Fi 6E refers to the frequency band that's been allocated to radio users. But you could easily imagine having Wi-Fi 7 protocols in the Wi-Fi 6E spectrum. In fact, I keep using the word Wi-Fi. So Wi-Fi 6 and Wi-Fi 7, these are based on 802.11 protocols. So typically associated with Wi-Fi, but could also be things like Bluetooth or Zigbee, but also unlicensed cellular products could be using that Wi-Fi 6E band. So with regard to the Wi-Fi 6E frequency band, typically the regulators it's technology neutral to an extent. It's not completely neutral. You couldn't just put anything in there. It needs to be some form of broadband radio access network, but it doesn't necessarily have to be Wi-Fi. Okay, so let's start in the USA with the FCC's rules and regulations. Radio equipment going into the Wi-Fi 6E band. So bear in mind, by the way, this presentation is about Wi-Fi 6E. It's that upper 6 to 7 gigahertz frequency band. This presentation is not about Wi-Fi 6 protocol. So radio equipment going into the Wi-Fi 6E band is considered unlicensed intentional radiator within the FCC rules and is covered by Part 15, Subpart E. So let's look at some of the spectrum bands that we've got for this type of equipment in the USA and how much extra the Wi-Fi 6E band gives us. So here are the traditional bands, and here's the new proposed band. Now, with that Wi-Fi, with that 5.8 gigahertz band, I've actually been quite generous there. I've put it going up to 5.895 gigahertz. Traditionally, it's been 5.85 gigahertz. The upper 45 megahertz is really only just being added. But you can see then we've got the 2.4 gig, we've got the 5 gig Wi-Fi or type equipment, and now we've got this Wi-Fi 6E at the bottom there. So you can see the amount of spectrum that was available prior to Wi-Fi 6E. Now with Wi-Fi 6E, we've got a lot more radio spectrum. You can see how much bigger that band is compared with all the other ones. So you can see, for example, if you had a 160 megahertz wide channel, that would be a really useful bit of spectrum. And when we look forward to Wi-Fi 7 and 320 megahertz wide channels, this Wi-Fi 6E band will really be important to us. So let's look at the FCC rules and what might be required. Well, there's equipment classes. Anybody who's familiar with manufacturing, testing, and certifying for the FCC hopefully understands about equipment classes. 2.4 gig Wi-Fi would be equipment class DTS. 5 gigahertz Wi-Fi would be equipment class NII. So now with the Wi-Fi 6E band, we've got these equipment classes in what the FCC is calling a sort of phase 1 rollout. You can see here we've got things like low power clients, low power indoor access point, subordinate indoor, low power indoor client. Lots of uses of the terms low power and indoor. Certifications are happening now. They've been happening throughout this year. In a rare moment of organization, I actually wrote these slides back on the 13th of May, and this was the number of products certified to each of those equipment classes on that date. Not on that date, but by that date. So when I checked on that date, that's how many products had been certified. So you can see they're still not huge numbers. Phase 2 then, this is a future phase, and they'll be rolling out additional equipment classes for the FCC, standard power access points, allowing basically higher powers and outdoor use. There are none of those at the moment, and that's simply because that equipment class is unavailable. And the reason it's not available is that the FCC is going to introduce an automated frequency coordination system, AFC. And this will allow those radios to work alongside each other. That AFC does not exist yet, and therefore it's not possible to have these equipment classes yet, and therefore the only types of device for Wi-Fi 6E band that you can test and certify at this time are those low power and indoor devices. So we use the terms uni bands, and all those different bands like the Wi-Fi bands have different names. And these Wi-Fi 6E bands are uni band 5, band 6, band 7, and band 8. If you wanted to take an existing product like a 2.4 or 5 gigahertz device and update the software such that it introduces or allows use of Wi-Fi 6E, that is possible through software updates, and it could be done through a Class 2 permissive change for the FCC or a Class 3 permissive change for Canada. But the application for permissive change would really need to clearly demonstrate that any software updates only apply to indoor low power devices. So let's have a look at the FCC scope of assessment. What do you need to test if you're going to the USA? Well, RF exposure safety. That's something Steve Liu's going to talk about after me. EMC performance or EMC emissions, for example, the Part 15 Subpart B requirements, and the radio transmitter performance. And that's what I'm really talking about today. So to go over some of the test methods for Wi-Fi 6E in the USA, there is a KDB. There is a KDB 987594. This is a published KDB. It's been around for a while. There's a testing section, an approval section. In fact, the approvals guidance section was last updated on the 27th of April. Some of the tests in that KDB point to KDB 789033. This is the general test procedures KDB for this type of equipment. So you can see then that the testing approach is very similar to those old 5 gigahertz Wi-Fis. It's funny calling them for old 5 gigahertz Wi-Fi when not that long ago they were the exciting new thing. The official test standard would be ANSI C63.10 because it's an unlicensed intentional radiator. Now, as a TCB, we are only allowed to certify products that have been fully tested to published and accepted test procedures. ANSI C63.10 is listed in the FCC rules, and KDB 987594 has been published and accepted by the FCC. So if the manufacturer and their listed test lab fully test to the correct standards and correct procedures, then a TCB is allowed to certify to them. A few exciting highlights from the FCC rules. Contention-based protocol. So this is a requirement that you don't see appearing, for example, in the 2.4 gig band. Up in the 5 gig band, we have DFS, but in the Wi-Fi 6E bands, we have this contention-based protocol. And it's a way for radios to share spectrum and work around each other. A good example of a contention-based protocol would be, for example, listen before talk, where the radio checks the spectrum is clear before it transmits. So Wi-Fi type devices are bound to be designed to meet this requirement, but you'll notice that the requirements don't state that it must meet, for example, 802.11ax, because to a certain extent, it has to be technology neutral. So each different radio service might have their own contention-based protocol solution. So you can see there's a nervous, gradual approach to the rollout of this technology, starting with low power indoor devices. There are some additional rules above and beyond the kind of traditional output power and spurious emissions tests you see with the USA. The access point or the extender or subordinate device must have controls so that you can't suddenly use it outdoors or at higher powers. For example, it must have an integrated antenna so that nobody could change the antenna. Typically, Part 15 devices do allow the user to change antennas if it's got a unique antenna connector, but that is not permitted for Wi-Fi 6E radios. It has to be an integrated integral antenna. You're not allowed weatherized enclosures, even if it's just for, ingress protection in an industrial environment, because any kind of weatherized enclosure could allow people to use them outdoors. Even though they're an indoor device, you can't use them for point-to-point services between buildings. And they must be mains powered access points so that people can't, if it's a battery powered, for example, people could walk around with them. And there must be security controls to ensure that nobody can put unauthorized software onto the radio. As I say, TCBs are certifying for phase one with these low power indoor devices, including portable devices, which will require SAR testing and power density testing because of the high frequencies. And Steve will talk about that after me. A pre-approval guidance procedure may be required for Wi-Fi 6E. At the time of writing these slides, there are two PAG codes applicable. And so in most cases, a Wi-Fi 6E manufacturer is going to have to go through the pre-approval guidance process, and you should budget for that when planning your projects. As with all transmitter certifications for the USA, the test lab must be listed on the FCC's website, and it must be accredited for this testing. For their lab listing, it would be under the Part 15 Subpart E. This is a general statement about the lifespan of an approval for the USA. Typically, it is a one-time certification. If you get a product certified for the USA, that's it. The certification remains valid. It's very unusual that the FCC rules themselves would change. If the test procedure or the KDB changes, then that's okay. If the FCC rules change, then you might have to update your certification. And that did actually happen with Wi-Fi, with 5 gigahertz Wi-Fi a few years ago. But if the KDB procedure or the ANSI C63.10 changes, your certification is unaffected. So now let's go to Canada. For Canada, you may know that you do not certify to like the Canadian rules as such, you certify to an individual standard. And in the case of Wi-Fi 6E radio, it's RSS 248. The standard is issue 1 and it was published on the 19th of November 21. And that means that we've been able to test and certify radios for the Wi-Fi 6E band since November 2021. RS 248 RSS 248 is the standard then, and it's very similar to the USA's FCC requirements. It uses the exact same frequency band. The test method is also the same, and ANSI C63.10 is the published KDB. The requirements are similar to the FCC. The FCC's KDB for Wi-Fi 6E equipment is not yet referenced by ISED Canada, but hopefully you can see that the test requirements are the same. Please always check that the limits and levels match because they don't always match between the USA and Canada. The test lab must be individually listed for the Canadian requirements, must be listed on the Canadian website with RSS 248 against their scope there, and with that standard on their individual scope of accreditation. The life approval span for Canada, again, it's a one-time certification, very, very similar to the FCC, but not exactly the same, because you're testing and certifying to an ISED RSS standard, and it will be updated. And when it gets updated, the manufacturer is expected to check that their radios still meet the latest version. The manufacturer must always keep up with changes. It doesn't necessarily mean your certification becomes invalid. Your certification still remains valid, but you are expected to keep checking any updates to the standard and make sure your radios always meet the latest version. So let's go across the Atlantic now to Europe, and we'll start with the European Union, the Radio Equipment Directive. The manufacturer's obligations under the RED are all in Article 10. Article 10.1 is to assess the radio to the essential requirements of the RED. Article 10.2 is to ensure that the radio can be used in the EU. And Article 10.10 is checking that which of the EU member states will allow it. And I raise this because it's really important whenever any new type of technology comes along. You can't just assume it's okay. You have to check that your product can be used. So how much new spectrum do we have in the EU? Well, here are the traditional existing frequency bands that we've had for a while now. And you can see sort of similar, very similar to the USA, slightly different in some cases. And now we have the Wi-Fi 6E band. This is very different to North America. For a start, the starting frequency is different by 20 megahertz, so 5.945 instead of 5.925, and then the upper frequency is a lot lower. Remember, it's 7.125 gigahertz for North America, but 6.425 for the EU. Interestingly, the original recommendation by CEPT was to start at 5.925 gigahertz, but the eventual European Commission decision settled on 5.945. So we can see we still have the biggest band up here, but it's nowhere near as the 1200 megahertz we had in North America. There is another little band in here, 5.725 to 5.875, and it's not really allocated to these higher power broadband radios in the EU. It's a lower power band for non-specific short-range devices, but of course people do put Wi-Fi type equipment in that band. It's important to remember that the RED is not a technical document. You won't find power levels and emissions limits. It's a trade document to allow products to move freely around the EU. Article 3 of the RED does contain a technical assessment to some essential requirements, though. All authorizations to the RED are through declaration of conformity, and the test cases themselves are not specified in the RED. For that, you would go and look at test standards. So the RED assessment scope covers product safety, EMC emissions and immunity, radio performance, transmitter and receiver, and other categories. Now, in the past, I wouldn't really have mentioned other categories, but if you're making a smartphone, for example, there is a requirement now from March 2022 that says that the phone must be able to identify its location and report to the emergency services if needed. And Wi-Fi is a big part of that requirement. And in August 2024, there will be some additional cybersecurity requirements coming into place. And at that time, this type of technology will need to meet that. So with the RED, you always have to start with your risk assessment. This should be the first document the manufacturer opens when they first start considering or planning a project, and the last document you close before you start shipping your product. If this slide comes as a surprise to you as a manufacturer, please get in touch because this is a big topic. So the first question you need to ask yourself whenever a new technology comes along is, can I sell it in the EU? This is the Article 10.2, and you mustn't always assume. Well, luckily in this case, there is a European Commission implementing decision, which includes all the frequency band and requirements of this Wi-Fi 6E band. Those frequency bands that I listed before and um, more technical detail are included in that implementing decision. That's where it states the frequency band. That's where it states that at this time, only very low power devices and low power indoor devices are permitted. Now, I said I wasn't going to start putting output power levels on my slides, but I can tell you that they are pretty low powers. This requirement is effective from the 21st of December 2021. So as of right now, you can be selling those Wi-Fi 6E devices around the EU. Sorry, I meant to say that they're expecting to re-review that Commission decision at the end of 2024. So whereas the FCC is going to has rolled out phase 1 already and is looking at phase 2 in the future, and Canada has issued issue 1 of RSS 248, and now they're considering issue 2. So the EU is going to re-review their decision at the end of 2024, and that's where they might consider higher power solutions. As for Article 10.10, well, it's a published and implemented Commission decision, and therefore every EU member state does allow Wi-Fi 6E equipment in that band. Are there any restrictions though? Is it a class 1 or class 2? Well, it's harmonized standards, so there's no restriction there, but for any of the indoor devices, there is a restriction. So indoor devices would be restricted, would be therefore class 2. Do I need to test it? Well, obviously for the FCC, you absolutely have to test in the correct way to the correct standard, and the same with Canada. Whereas in the EU, of course, the red never mandates testing, but everybody does test because it's the easiest, most recommended route to compliance. You must assess your radio for compliance, and testing is the most simple way. You have a choice of test lab. There's no listed labs for the EU, and you don't have to use an accredited lab, but you'll be signing your DOC based on the results. What standards should I test to? Well, the dream situation is to find a harmonized standard. ETSI is the group responsible for writing radio standards, and if they issue a standard and it gets voted and becomes a harmonized standard, and then the European Commission lists it on their official journal for the Radio Equipment Directive, then we call it a harmonized standard listed on the OJ, and it gives presumption of conformity. But for compliance to the red, you don't need a harmonized standard listed on the OJ. You can use non-harmonized standards. You can even use draft standards if you need to. And if the harmonized standard is not listed on the official journal, then you would need a notified body for the radio parts. The standard for the Wi-Fi 6E band is EN 303687. And the timing of this webinar is good because this standard got published in a draft form to go on approval in version 1.0.0 in April 2022. So it's in the ENAP stage, approval procedure process. There'll be comments, responses, and eventually we hope ETSI will be able to vote on that and publish it as a harmonized standard. They hope to publish it around the end of January 2023. The European Commission will then receive the standard, and once that standard is listed on their official journal, it will provide presumption of conformity. The hope or the plan at this stage is that it would get listed on the official journal around May 2023. But of course, don't pin all your hopes on that date. So a few highlights then from EN 303687. Pretty similar to the 5 gigahertz Wi-Fi approach. I said that there's the very low power and the low power indoor devices, and you can see there that EIRP levels are not especially high. It is technology neutral, of course, as long as it meets the requirements of the standard and it fits in the scope. So it's a broadband radio access, but it doesn't have to be following the Wi-Fi protocols. It could be like an unlicensed cellular type of communication, unlicensed Wi-Fi as LTE or 5G, for example. Some highlights from within the standard. There are tests for the frequency accuracy and the channel bandwidth, the transmitter output power and power density, the spurious emissions, and the spectrum mask. There are channel access mechanisms similar to the contention-based protocol that we saw in North America. receiver selectivity and blocking, which is included in all RED standards. There's some requirements in the standard about the mechanical setup and the electrical design. And this is where it talks about the product must not have a weatherized enclosure and it must not be battery powered because, of course, the products have to be for indoor use only. So if you break that requirement, you wouldn't meet the harmonized standard. And there's also user access restrictions such that the user can't access the software to change any of those important radio parameters. With regard to authorizing and CE marking and the manufacturer's declaration of conformity, the manufacturer can assess to any standard, so it doesn't matter that the standard is draft or at the ENAP stage. The notified body type examination certificate is mandatory for Wi-Fi 6E at this time because the standard is not on the official journal. The RED states that the notified body can only issue a TEC if the product can be used in the EU and the regulation exists for it. Well, the Commission decision is there and all the countries allow it, so we know that we can proceed with that. The standard isn't listed on the official journal though, and the notified bodies are expected to understand the situation with the standard and be aware if there are any problems. The manufacturer's risk assessment must always include details if the manufacturer has used a non-harmonized standard. For example, the manufacturer is expected to justify why they thought that standard was the correct one. And that's because the standard does not provide presumption of conformity. Again, if this is confusing to you, please get in touch. So the REDS assessment scope covers product safety. We haven't really talked about that today. EMC emissions and immunity. We haven't really talked about that today. Radio performance. This is what we've been focusing. The other categories. I'm sure you probably got some questions about cybersecurity. The cybersecurity requirements don't apply until August 2024. That would be the earliest you could start trying to demonstrate compliance with that requirement. Okay, so let's move across now to Great Britain, which is no longer in the EU, of course. And we have the UKCA mark based on the UK's radio equipment regulation. So the UKCA mark applies to Great Britain, and it's not quite the UK. I do wonder if they might have called it the GBCA mark if they had thought it through a little bit better. It applies from the 1st of January 2021, but for now until January 2023, CE marked radio equipment is permitted into the UK or into Great Britain if the technical requirements match. So any change in the spectrum compared with the EU for the UK? Well, yes, actually, here's the common bands. This was that one frequency band which I said was only very low power for non-specific short-range devices in the EU, whereas the UK allows this band sort of higher power wireless LAN types of device. And there's the Wi-Fi 6E band in the UK. Now you'll see that they did go down to the lower frequency band in the UK. So the start frequency is different in the UK than it is in the EU. Can you sell it in Great Britain? Remember, the UK is not in the EU, and therefore that implementing decision from the EC does not apply in Britain. However, Britain does have its own frequency allocation tables and it does have its own documentation. There's an interface regulation 2030 where it has adopted that frequency band and listed those devices. So yes, you can use them in the UK or in Great Britain. The UK's radio equipment regulation is very similar to the EU RED. I would even go so far as to say there was some copy and paste applied when the UK created their radio regulations. Manufacturer does assess their product for compliance to safety, EMC and radio. They don't have the cybersecurity or emergency calling regulations in the radio equipment regulation, although they might implement them separately. And again, the manufacturer is expected to use the most appropriate standard. And again, EN 303687 is the appropriate standard. The manufacturer can use any test lab they like. There's no listed list of labs for the UK. And if the manufacturer wants presumption of conformity, they need to find a standard which is on the UK's designated standards list. That's very different to the EU's harmonized standard list. Of course, EN 303687 is not a designated standard for the UK yet, and therefore a UK approved body would be needed for a type examination certificate. A general statement about the EU and Great Britain, and I want to talk you through this procedure. And maybe you know this already, but the process is to assess a radio product, label it with the CE mark or the UKCA mark, get a notified body or approved body certificate, create the declaration of conformity, maintain the technical documentation, watch for any changes, and if there are changes, return to the assessment phase. This is pretty standard stuff, but I'm adding it here because, of course, the standard is only just on the ENAP stage, so it could easily change. So if you want to go ahead with Wi-Fi 6E technology now, you've really got to keep your eyes on that Wi-Fi 6E standard. At the moment, following the red strictly, if you want to get a type examination certificate for a draft or a non-harmonized standard, and then the standard changes, the certificate becomes invalid pretty much immediately. As a group of notified bodies, we are trying to work with the European Commission to allow some sort of transition period, but there's nothing in the red to allow it. Okay, so some global headaches facing anybody with new technology. New technology, early adopters. Do you want to be first out there on the market, or do you want to wait and see if things settle down? Well, being first on the market is great. It's a wonderful big chunk of radio spectrum, but the standards are all very new, the regulations are very new, the tests are pretty new, and the approval process is pretty new. So you're going to be using draft standards for Europe. You're going to be going to a notified body for the Europe and approved body for the UK. The test equipment is all going to be new, and for example, for the USA, you're going to have to go through the pre-approvals guidance process. For anybody who's bought test equipment, you'll know that when a new type of technology comes along, the new equipment is always very expensive. So the untrodden path is a great way to get to market early, whereas it also can be quite costly. So the road less traveled to be the first to market is a great thing, but it will cost more. So simply saying I'd like a 2.4 gig Wi-Fi test is going to be a lot cheaper than saying I'd like a 6E Wi-Fi test, and a lot quicker too. Okay, so questions, but we're going to wait until Steve has finished talking. So I'm going to hand over now to my colleague Steve Liu, and I'll see you for the Q&A session. Thank you.
All right, thanks, Michael, for the thorough presentation on Wi-Fi 6E and the RF testing aspects, and also Laura and Allison for organizing this for everyone. So my name's Steve Liu, and I'm the Vice President of Engineering at Element for our Connected Technologies Americas unit. And I've been working with SAR and RF safety since 2000, and it's been really exciting to see, how we just began with Bluetooth and Wi-Fi devices, and now evolved into 5G and also this new Wi-Fi 6E spectrum opportunity that a lot of manufacturers will like to take advantage of in this year in 2022 and also beyond. So I'm going to focus on the latest human health and safety aspects that regulators are looking for currently, and also some comments and suggestions for manufacturers and other people who are looking to get into the US and Canada for approval, and trying to understand the approval process for their future Wi-Fi 6E products. So first of all, for those who aren't familiar with SAR, it's a metric that the industry uses to evaluate how much tissue heating the human head or body or extremities may experience over a given period of time. And the theory is that using E-field measurement probes, like the picture there, we can correlate the SAR levels and hence tissue heating potential of wireless technologies just by measuring the electrical field levels in a given simulated tissue in a head or body structure. And here are a couple pictures of what a SAR robot looks like. And some of you may have these or have seen these in your test labs. We have a combination of DAISY 6s and DAISY 8s from a company named SPIAG in Switzerland. And they've been great in partnering and helping us develop and test Wi-Fi 6E technology for regulatory approvals. So a quick overview of the frequency bands in Wi-Fi 6E that Michael spoke to earlier. There are four main unibands of operation, where in the RF EMC test world, it's treated completely separate with its own, indoor, outdoor, rated power requirements, etc. But for SAR and RF exposure, there are two main sections that have to be considered separately. So one, where the frequency is less than 6 gigahertz, it's not cleanly defined in uniband 5, except for the channels below 6.0 gigahertz, which is somewhere around below channel 9. And the other frequencies above uh, is what's called the transition frequency. And the theory is that above 6 gigahertz, the SAR would underestimate the skin exposure, while absorbed power density is the more appropriate measure of exposure to the human body, and more suitable for measurement against the basic restrictions. So to give a few definitions and notes, SAR is what we all love and know that apply by definition to the sub 6 gigahertz frequencies, although it could be measured up to 10 gigahertz. And APD is absorbed power density, or epithelial or skin power density, and is defined as the energy flow per unit area directly under the body's surface. And that quantity is based on the Poynting vector. And PD is short for incident power density, which could be IPD, or often just referred to as just power density. And something to point out here as far as the problem with PD is that the value is underestimated when quantities are considered near the human body due to the reactive near field effects. And according to a BioEM paper, when you go farther, there's also backscattering effects, which are caused by reflections from the body and the device that can occur as well. So what's the difference between SAR and PD when you're filing something to the FCC? So SAR has the usual liquids and uses a SAM phantom to position devices to head or body structures. But one of the benefits of SAR that for the hand, there's a 10-gram quantity where the FCC limits are at 4 watts per kilogram over 10 grams. But head and body are 1.6 watts per kilogram over 1 gram. And for PD, this is all done in free space. Because there's a single limit for all exposures, regulators require that compliance is shown at the surface of the device. And this is typically done at 2 millimeters to align with the 2 millimeter shell of a SAM phantom that we know in the SAR world. But as we discussed, this puts us in the highly reactive near field. So using the result measured at the farther distance, you can use these two values to determine if the measurement resolution at the 2 millimeter close distance was fine enough. And I know for those labs using DAISY systems that this company is working on an update to improve the software handling of the measurement uncertainty. But for now, we're measuring two separate distances to account for the uncertainty aspects. And a note related to the hand and extremity, the PD measurements actually don't have a similar relation for the hand, which will be problematic for devices like smartphones that require a lot of simultaneous transmission, summation calculations. So that's something to keep in mind. A few more FCC-related testing notes. So there are a few systems out there calculating the APD from the SAR results, and I mentioned in there DAISY 6 and DAISY 8. And a few FCC workshops ago, they allowed 5 channels to be measured across the large Wi-Fi 6E band, which is good. So to summarize for the FCC, 3 quantities need to be measured at the lab. So there's SAR and there's APD, which is just for reference for the FCC. It's not nothing's done with those, but they check it against their internal notes. And PD, which are measured against the actual FCC limits in the rules. And this really is the main reason why they require the measurement, the PD measurement. It's just because it's in the rules. And although APT is actually a better quantity to capture that 6 gigahertz exposure. And here's just a table showing the different FCC limits that I just mentioned here. Now, similarly for Canada, there are also limits defined in Health Canada's Safety Code 6 publication. And since they defined APD limits for the Canadian approvals, your products just need to test for the APD and SAR quantities and not the PD quantities, since portable devices are only appropriate using APD in the near field. So just to quickly summarize for the ISED Canada, SAR testing is done as well as the APD. And just a note here to follow the currently, as of today, the draft publication SPR APD, if you want to be compliant for the approvals for portable devices in Wi-Fi 6E. So finally, a few things. If you've never filed the Wi-Fi 6E device to the FCC before, is that it requires pre-approval guidance or the PAG process. And the last item on the PAG list applies for Wi-Fi 6E products, UN 6 gigahertz. But the first one applies if it's a portable product, meaning something that could be used to the head or body or on the hand or something transportable on a tabletop. And here's just a visual to describe the process when regarding FCC. And of course, one would test the Wi-Fi 6E to all the requirements. So, a competent test lab should help you with that. And next, the TCB should be doing a good job to review the reports and the documents to ensure that there aren't delays when you get to the FCC review stage. And invariably, when labs and TCBs don't do a good job and rush to skip steps, then the PAG time takes a lot longer and delays are just not good for anybody. So really taking care of these steps over here will help your approval to get through without any problems. And for Canada, for portable devices, as of today, the SPR APD isn't published, so this pre-review process applies, meaning the government of Canada wants to take a look at the reports and other associated documents to see how the test lab applied the requirements prior to certification so that everything can be smooth at the end. So to conclude about Wi-Fi 6E, it's a promising technology that's really going to accelerate our more connected world, no doubt. But others probably have want to pursue the same pursuits, and we recommend, especially if you have a product in development, it's never too late to talk with your lab or TCB about the strategy on making sure that there's going to be no delays or surprises to avoid any unnecessary delays for your launch or your shipment schedules. And that's pretty much it for my part of the presentation. And not sure if anyone's questions, but maybe at this time I'll just hand it over to Laura and Allison to moderate this section for us.
Thanks, Steve. And before we go over some of your questions, we wanted to give you a very brief overview of Element. Element is one of the largest independent providers of materials and product testing services in the world, providing high-value critical services to the aerospace, transportation, life sciences, and connected technologies sectors. We have over 6,000 global experts across 200 locations and 30 countries.
Our purpose is a simple one. Our goal is to make tomorrow safer than today. We help our customers make certain that their products, materials, processes, and services are safe, compliant, and fit for purpose. And our aim within the Connected Technologies division is to ensure we deliver on time, every time, from R&D innovation to marketplace reality.
This is underpinned by everything Element does, and our values are based on integrity. We want to do what is right for both our customers and for each other. Care, Creating a safer world starts with us caring about our customers. Our culture is inclusive and everyone is welcome. And progress. We strive to make a more positive future, and we grow and learn by constantly thinking about our impacts and how we can do better for each other and society.
If you do have any questions, please reach out to us via the website, by phone, or by emailing us using the above links.
Now we'll turn to your questions. Thanks for getting involved and submitting those questions. We'll now hand back over to Michael and Steve to go over these.
During the testing, do we need to power off the intended radiators like Wi-Fi 2.5 gigahertz and 5 gigahertz, and why?
Okay, Steve, if you're happy for me to answer this one. So assume this is during the sort of EMC and RF testing. Now, usually with compliance, and this doesn't just apply to Wi-Fi 6E, this is for any region, to make life simple, standards are written around like a technology, you know, like there'll be a test for 2.4 gig Wi-Fi, and then you'll do a test for 5 gig Wi-Fi, and then you'll do a test for 5.6E Wi-Fi, whatever, and then maybe LTE, Bluetooth, NFC, whatever your radio does. And then you might turn them all off and do a test of the general electronics. So in theory, or in general, each thing is tested individually. However, there is a clause in the FCC rules that says if your product's got multiple transmitters, that they should all be on during the testing. But that doesn't mean you have to force them into some unnecessary mode that isn't real. It means if they would be on in real life, then they need to be on in the testing. So let's say, for example, you've got a hotspot where LTE and Wi-Fi would both be on in normal use. What it means is when you're testing the Wi-Fi, turn the LTE on as well. And so if you've got other transmitters, you would turn them on if they would be on at the same time. But my guess is if you've got a Wi-Fi of like 2.4 gig, 5 gig and 6 gig, probably it would only be transmitting on one at a time in real life. And so you'd probably be jumping around while you test each channel just to that channel. I think if I understood the question correctly.
Yeah, and I think for the RF exposure, definitely testing each band, frequency band separate, because their probes can only handle one narrow band at a time. And when there are simultaneous transmissions, then the lab would do a superposition of the technologies to ensure it doesn't exceed the limits. So it's kind of similar.
Great, thanks guys. Next question, how to tackle the challenges with 2.4 gigahertz and 5 gigahertz testing when the 6 gigahertz band becomes prominent?
Okay, so it's an addition, it's not instead. So if you've got a device with 2.4 gig and 5 gig Wi-Fi and you've been used to testing them, if you enable the 6E band as well, then you test that as well. It's not a case of saying, well, if I test the 6E band, I can probably assume that the 5 gigahertz or 2.4 gigahertz bands pass. It doesn't work like that. In fact, the FCC clarified recently, if you look at those the 6E frequency bands, you can see it was like 1200 megahertz wide. And there's a term uni bands, and these are sort of Wi-Fi terminology, but it's split into uni bands 5, 6, 7, and 8. That makes up the Wi-Fi 6E chunk of spectrum. And actually the FCC clarified recently that they want to see bottom, middle, and top testing of each uni band. And I guess that's in case you're just turning some bands on and off, you need to be able to show that the band you're using can comply. So yeah, it's an additive thing, I think, and I think Steve would agree with RF exposure. It's in addition to the other testing, not instead of.
Okay, thank you. Let me just have a look at the next question now. 1 second. The implications for host device manufacturer and without co-location.
Okay, so I guess this is radio modules. So if you had a module, Wi-Fi 6E radio module, then the implications for the manufacturer installing that, or the host manufacturer installing that, would be that they would need to make sure they only installed it, for example, in an indoor product if it was an access point. Obviously, if it's a client device, it could be in an outdoor product. I know that Steve's done some work with sort of cell phone RF exposure Wi-Fi 6E. Typically, if you're going to put a radio module into a small product like a phone or a tablet where RF exposure testing is needed, then the host manufacturer has to do a final product certification. And so as for co-location, I'd say you're going to treat it just like you do with any other radio thing where you've got to consider the co-location. I mean, I guess, Steve, if you're having to consider the co-location between something that's above 6 gigahertz and below 6 gigahertz, if it's mobile, then I suppose it's just an MPE calculation still. And if it's portable, how do you need to add somehow the power density and the SAR? Maybe you covered this in the slides and I maybe missed it.
Yeah, pretty much if you have additional Wi-Fi 6E that will be co-located with other transmitters, obviously you assess the Wi-Fi 6E standalone, but then any interactions or simultaneous transmissions capabilities, you have to add the additional analysis just to ensure that whether you're summing the APD, SAR, whichever country you're trying to comply with, that it'll also comply. So for example, in the FCC, you have this TER measurement, which is basically sort of this hybrid sum of SAR and also power density, just to ensure that the sum of the ratio of the limits don't exceed the limits. So yeah, there's some additional things that you do after the fact that you test the standalone technology.
Great. Well, we do have a question that's come in. Somebody's asking, can you clarify again if during RF exposure for multi-radio device, should all technologies be enabled simultaneously?
Yeah, I can answer that. So during the RF exposure assessment, the electrical probes are only capable of measuring a narrow frequency, so you actually need to turn off everything else. So if it can do simultaneous, you actually have to rely on the system equipment to do the manual superposition. So if you have Wi-Fi that can work with 5G, for example, you have to test the 5G band by itself separately, and then you test the Wi-Fi 6E separately. And then once you have those plots or those contours, then the software can combine them, or you can numerically combine them. And then once you check it's below the limit for every space on the head or body, then you're good to go, and the reports have to show that.
Okay, thank you. So just go over to our next question now. With the standards still in draft level, how do other countries approve or monitor the devices that are set to be Wi-Fi 6E disable?
Okay, well, I mean, I think in general, when you've got a frequency band or a type of operation that's allowed in some countries but not in others, this is always a big challenge for manufacturers, because a manufacturer wants to sell one hardware solution and sell it around the world, and then each different country may or may not allow it. So, in the USA, they come out quite clearly and say you can't have country code selections if you're trying to, if the country code could turn a radio on or off. So for example, if you're letting a product into the USA that uses some other thing, you wouldn't be allowed to turn it on. And the same goes for the EU. You can't use software to turn on frequency bands. So if you've got other countries, they would have those same sort of requirements, I should imagine. The fact that the European standard is still in a draft format, I don't think affects that, because you would still use the draft or non-harmonized version of the standard to show you're compliant with the EU's requirements. The only thing I would say that the trouble is, so how with Europe you do not need an accredited test lab. So you could have a test report that's not from an accredited lab, and that's perfectly legal and it's perfectly valid. And that's fine, because you can use a draft standard or a random test plan, or so the standard for ETSI at the moment is a published standard on the approvals process, but it's not published final, and it's certainly not listed on the official journal. So you wouldn't be able to get, a test lab wouldn't be able to get accredited very easily to that standard, because up until 3 or 4 weeks ago, it wasn't even a PDF document. It was literally a Word document with track changes down the side. So you wouldn't have labs that are accredited for it. That's okay for Europe, but there are a lot of countries in the world that say, we will rely on a European approvals approach, but we want the test report to be accredited. And so people, for example, they come to us and say, we need an accredited test report. We know it's not needed for Europe, but we're going to some other countries. So for a really new draft standard like this, that would be a hold up, I should imagine.
Great. I think maybe we have time for one more question, but anybody that we weren't able, we got a lot of questions here just coming in. So for any that we're not able to answer, we'll send out the answers with a recording of this webinar after the session concludes here. So
can I request? Oh, sorry. I've seen a good one about EMC, EMS.
Yes,
testing.
let's do that one. EMC, EMS today goes up to 6 gigahertz. Will this be going beyond 6 gigahertz with Wi-Fi 6E?
Yeah, that's a good question. So I think when you say EMS, you are saying electromagnetic susceptibility or radiated immunity testing. So when I was a little boy, EMC immunity testing was always up to 1 gigahertz because there was nothing transmitting above 1 gigahertz. And then when I was a slightly older little boy, it went up to 2.7 gigahertz. Nowadays, I'm still very young, but it's all the way up to 6 gigahertz. So you test radiated immunity up to 6 gigahertz. It feels like only very recently that they made that change. It's actually years ago that they added it up to 6 gigahertz. But a lot of people are still getting used to that. And the logic was, there's no radio services above 6 gigahertz. Everything's below 6 gigahertz, or most of the stuff around our homes is 6 gigahertz and below, so that's fine. So yeah, will radiated immunity now be extended beyond 6 gigahertz? This isn't the first time I've heard that question. And so yeah, I think it's probably they will. I know that for a fact that one of the things they're looking at with radiated immunity is the interfering signal historically is, just a CW signal with 80% AM modulation, and they're looking at replacing that with a broad LTE style signal or a Wi-Fi style signal, so it's a bit more real life. And so yeah, they're kind of looking again at the radiated immunity standards. There's a work item in place at the moment to try and look and say, is it appropriate for 2022 and beyond? And so I think frequency band will be part of that discussion. I haven't seen anything to make it clear. I think one of the stumbling blocks will be that everybody's just bought spectrum signal generators that only go up to 6 gigahertz. So maybe it will depend when they can roll out ones that go up to 8. Cool.
Okay, thank you.
If you had another one you wanted to ask, then please go away. Please go, go ahead and ask. Not go away. Please go ahead.
Well, we've got a few more questions. So I mean, take your pick, Michael. Is there one that you'd like to answer? Another one you think is a good one?
I saw one on the sort of on the registrations that said, why is the power spectral density limit for indoor client devices limited to -1 dBm per megahertz? I guess the question is, why is the power density so low? So there's two parts to that, I guess. There's the output power test. They want the power to be low because it's this really sort of gradual, nervous rollout. It's indoor use only, or if it's going to be outdoors, then it can be low power. One quick comment about cell phones. Obviously, a cell phone can be a client device for Wi-Fi 6E, and we all know that you can walk around outdoors with a cell phone. And the FCC and I said, they're like, yeah, we understand that, but you're probably not going to go far from the house because we're going to assume that the access point is in the house. So you'll probably be using your Wi-Fi 6E in the house. It is true that you could probably still get your Wi-Fi 6E signal in the garden, but in general, when you're outside, you're going to be using cellular, and so that's how they get around that. Sorry, I'm diverging here, but yeah, why is the power level so low? It's all part of that nervousness. And then why is the power density so low? And that is because they're trying to keep the band for really broad signals. So spreading, there's two ways of doing spread spectrum sharing. So sharing a channel with lots of people. You can either have a narrow signal that randomly hops around like Bluetooth does, or you can have one channel that is really broad such that the average power per individual megahertz of spectrum is very low. And so to have a high-ish power level and then a much lower power density level is basically a way of saying you can't have a neat, narrow, discrete signal that doesn't move. If you want a signal that's going to sit there and not move, it needs to have spread all its energy out across so that other people can use the spectrum as well. It's all about spectrum sharing, basically.
We did have a quite nice sort of pre-registration question, which I'll just read out if you don't mind going through that one. So one of the questions we had before the webinar was, why is the PSD limit in 6E channels for indoor clients limited to -1 dBm/megahertz?
Cool, thank you. Laura, can you hear me okay? Cool. Okay, yeah, so interestingly, we answered this question this morning, but in a really general, why would the PSD value be lower than the total power value? So the limit in a rule part might say you can have this much power, but the power spectral density must be this much, and it's a way of making sure that the signal is spread. And so, yeah, this morning I gave a very general answer that that's what the power spectral density is all about. But afterwards I thought, well, you know, talking with Steve, realized didn't really answer it specifically to Wi-Fi 6E, like why in this specific case is the power spectral density level so low? And the answer is that the FCC is trying to discourage use of narrowband signals. So Wi-Fi 6 is backward compatible to earlier versions of Wi-Fi, you know, like narrower bandwidths and more simple modulation. But the FCC really wants the manufacturers to use this Wi-Fi 6 protocol, Wi-Fi 6 and above protocol in the Wi-Fi 6E band. So they want the big wide channels to be used. And that would be how the manufacturer could meet this really low power spectral density level and have a nice usably high average power in total. So hopefully that's a slightly more complete answer than the one that I gave this morning, which was basically just explaining what power density was. Cool.
Great.
Okay.
Next question that came in was, during testing, do we need to power off the intended radiators like Wi-Fi 2.5 gigahertz and 5 gigahertz, and why?
Okay, so I think Steve and I can both answer this one, but from different points of view. So if I go first with the kind of EMC and radio point of view, if you've got multiple transmitters in a product, then you're supposed to turn them all on during the testing. So let's say you've got a Wi-Fi and LTE hotspot or router. So when you're testing the Wi-Fi, you're supposed to have the LTE switched on as well, just to see if having it switched on would interfere with the Wi-Fi or would make the emissions worse. And there's a specific clause in the FCC rules that says that all transmitters must be on during testing. And similarly in Europe, of course, the manufacturer, each individual standard would never mention that, but the manufacturer is expected to test in a worst case mode, which would most likely be with all the transmitters on. But that doesn't mean you have to force the product into an unnatural mode. So if you've got a Wi-Fi device, it's probably unlikely that it would use 2.4 and 5 and 6E bands all at the same time. So that the FCC requirement to have all of the transmitters on is only if that's a normal mode. So that's how it is, I guess, for EMC and radio testing, is if it can be on, then it should be on. But for RF exposure testing, I believe that's a bit different. So I'll leave that to Steve.
Yeah, I think when it comes to RF exposure, if your product has multiple transmitters and operates in, 2 or 3 different frequencies and can do it at the same time, the system equipment electrical probes are very narrow in frequency in the way it captures and the way it translates it to SAR level. So you actually need to turn on one single transmitter, make the SAR measurement, and then turn on the second transmitter, make that SAR measurement, etc. And then once you have the contours of all of them on the same exposure, you do superposition or you sum them to check to make sure it's compliant. So, but for the SAR test, you don't turn on everything because the probes will wrongly capture the other frequencies. So you have to do them separately and add them later together, whether manually or through software.
Okay, thank you. We've had another question come in as well. They're asking, do we know at this point how Wi-Fi 6E might impact host integrated device testing and certification requirement?
Okay, yeah, so this refers to radio modules by the sound of it. So yeah, at the moment you can get a modular approval on a Wi-Fi 6E device, I believe. And so you could install that into a host product, and we're talking USA obviously here because there isn't a modular approvals route as such in Europe. How does it affect the impact of the integration testing? Well, the same as any other radio in most cases. So for example, if you install a radio module into some other product, your basic electronics part 15 subpart B EMC emissions testing, that always needs to be done, and you test up to the highest frequency generated in your product, which before you put the radio module in might have been a clock or processor, but now suddenly you've got a 7.125 gigahertz signal in your product. So your part 15 subpart B emissions testing goes up to a much higher frequency because you've got that clock in there. And then as the installer or the integrator, you're still responsible for checking that the module or the final product, sorry, would or could pass the transmitter tests. Doesn't mean you have to repeat all the tests. Transmitter spurious emissions is the most common one. So again, if you were to change the antenna, for example, or the RF exposure condition, then you might have to do a class 2 permissive change. Or if the host was a small portable device like a cell phone or a tablet, then you'd need to get the end product certified. You couldn't rely on modular approval for that. So really, from that point of view, the same as any other module. The only things I would say that are different for Wi-Fi 6E, of course, are that if you've got a sort of access point or subordinate, it has to be going into an indoor-only device. It has to be going into a device that doesn't have any weatherized enclosure, doesn't have battery powering, anything like that, because it still needs to meet those requirements. Cool.
Great, thank you. Well, we have a couple questions here too about wireless coexistence for medical devices and how this would impact your medical device. And I think that could be an entire webinar in of itself, but I wonder if you guys had any commentary on that.
Yeah, so whenever you do a medical device, if that device is medical enough that you need to get the FDA involved, then there's wireless coexistence testing. And I'm not an expert in that, and it might well be that I take those questions and pass them on to one of my colleagues who is. The little that I know about it is that it's all based around a risk assessment by the manufacturer based on the type of medical equipment, the type of radio technology they've got in the medical equipment, and the type of other radio equipment you're going to have around you. So it's all based on sort of coexistence risk assessment that would keep the FDA happy. So I think maybe I'll take a note of whoever asked those questions and put them in touch with somebody in our medical team.
Great, thanks.
Cool.
Thank you. I think that's all of the questions, unless anyone's got any last minute ones they want to quickly post. But yeah, that brings us.
There was one question I saw come up that somebody they'd heard about the indoor part, and so they said, so could you not have Wi-Fi hotspot mode on a smartphone if the smartphone supports Wi-Fi 6E? And there's a good point. So hotspot mode, normally your phone is a client device from a Wi-Fi point of view, but you can set your phone to hotspot mode where your phone acts as the access point. You can have Wi-Fi 6E in your phone, and the phone can be the client device. Now, you might be thinking, hang on a minute, a phone isn't an indoor-only device. You could walk outside with your phone, and the FCC accepts that the access point is indoors. you'll probably be using the Wi-Fi indoors. But yeah, one of the questions, or even just outside the door. But yeah, one of the questions was, does that mean you can't use hotspot mode on a Wi-Fi 6E enabled phone? And it simply means that you can't use the Wi-Fi 6E band for the hotspot mode. In the same way as there are 5 gigahertz Wi-Fi bands that are for indoor use only. And so you can't use that band for the hotspot mode either. Typically, if you've got a phone that has 2.4, 5, and 6E bands Wi-Fi, it could use any of those as a client device. As soon as you click hotspot mode, it will default to the 2.4 gigahertz band or one of the other bands that allows outdoor use, but it wouldn't use the Wi-Fi 6E or the indoor 5 gigahertz bands for the hotspot mode. Cool.
Great. Okay.
All right.
Well, I think with that, we'll wrap up for today, just a few minutes over. We really appreciate everyone's time today, and thank you for joining us. We'll send out a recording of this webinar after the fact, and you can get in touch with us at any time. We'll put people in touch with the specific medical experts as well. So thank you very much, everyone, for joining.
Cool. Thanks very much.
Bye.